everyone. This is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. In this lecture, we'll discuss some problems on common emitter configuration. That is, we'll discuss some problems on common emitter amplifier. That is, analysis of common emitter amplifier using hybrid parameter model. So, first of all, what are the parameters that we are going to calculate are the impedance, input impedance, and voltage gain, current gain, overall voltage gain, overall current gain, and the power gain, and also the output admittance Y naught. So first of all, these are the steps for analyzing any transistor circuit, not only amplifier, any transistor circuit. If we want to do some AC analysis, so this is the procedure. So what is the procedure? So as we are doing the AC analysis, calculation of all these parameters, that means of amplifier, means that we are analyzing, we are doing AC analysis of transistor circuit. So what are the steps involved in the analysis of transistor circuit, that is AC analysis of transistor circuit? First, draw the circuit as usual, that is draw the actual circuit. And in the second step, replace all the coupling capacitors and emitter bypass capacitor by short circuit. So here we need to short circuit all the coupling capacitors, and even if we have any emitter bypass capacitor, that should also be short circuited. So next, replace the source, DC source, by a short circuit. That means we are providing some DC bias, right, for the amplifier in order to for the transistor in order to control the region of operation. So all the DC sources must also be grounded. That means we need to short circuit all the DC sources, make all the DC sources 0, and then mark the terminals of the transistor, that is base, emitter and collector, and locate these points as the start of equivalent circuit. And final step is replace the transistor by its H parameter model. So this is the equivalent circuit of a transistor. So replace the transistor with its equivalent circuit, which is nothing but H parameter model. So these are the formulae that we need to remember when we are analyzing the various characteristic parameters of transistor amplifier. What are those? Current gain. The formula is minus HFE by 1 plus HOE into RL, where RL is the load resistance, and all these are the H parameters. And RA is equals to HIE plus HRE into AI into RL. So this is the equation for finding out this RA, that is the input impedance or else input resistance, whereas we can substitute IARE formula in this one, where AI is given by minus HFE by 1 plus HOE into RL. And next, voltage gain can be calculated from the formula AV is equals to AI into RL by RI, where RL is a load resistance and RI is the input impedance, so which we are calculating from this equation. And then output resistance is given by RS plus HIE divided by RS plus HIE plus delta H, where delta H is HIE HOE minus HRE HFE, or else we can also have the formula for Y naught, that is HOE minus HRE into HFE divided by HIE plus RS. So this is the equation for Y naught. If we got Y naught, R naught is simply calculated by taking the reciprocal of Y naught. So this is also another formula for calculating output admittance. So next, the values of various H parameters. If the values of H parameters are not given, we need to use the ideal values or else typical values of H parameters. So these are the typical values of H parameters for all the 3 configurations of a transistor. So that we need to remember. If it is not given, we have to recall these H parameter values and we have to use them. Now let us take the first problem on common emitter circuit. The common emitter circuit has the following components. R1 is equals to 27 kilo ohms, R2 27 kilo ohms, RE 5.6 kilo ohms, and RL 4.7 kilo ohms, RS 600 ohms, And the transistor parameters are HIE is equals to 1 kilo ohm, HFE is equals to 85, and HOE 25 microamperes, and here HRE is not given. HRE value will be 2.5 into 10 to the power of minus 4. So 2.5 into 10 to the power of minus 4, it is reverse voltage gain, so there are no units here. And determine these parameters. What are those? AI, RI, AB and R0. So first of all, this is a common emitter circuit which are having various parameters which are given here. Now I want to draw the circuit. So common emitter circuit, so the transistor is connected in common emitter configuration where we do have a resistance RE, and wherever we have a resistance we should have a coupling capacitor, that is CE, and here we have RC, that is RL. Okay, RL is given. What is the value of RL? 4.7 kilo ohms, and we do have two resistances here. That means here the common emitter configuration is connected in voltage divider biasing. So this is RS. Okay, so RS, which is equals to 600 ohms. RS value is given, which is 600 ohms, and we have a voltage source. Okay, so this is voltage source Vs, and these are R1, R2, where R1 and R2 are also 27K, and here this is, and here we are taking the output across the load resistor. So this is the circuit we have, and this is the plus VCC. This is a common emitter configuration circuit diagram. So this is a coupling capacitor C1. Let us have one more capacitor, that is C2 here, and this is the emitter capacitor. So what I said, according to the procedure, first we need to draw the equivalent circuit of this one whenever we are doing AC analysis. So whenever we are doing the AC analysis, all the capacitors should be short circuited, and also the supply voltage, DC supply voltage, should also be grounded. So if I ground this one, if I connect this to ground, then RL will now be connected between collector and the emitter terminal. This is collector, base, and this is the emitter, because this is common emitter configuration. So as it is grounded, so now R2 is anyhow connected between base and ground. Now R1 will also come in parallel with R2, which is connected between base and ground. So now let us draw the equivalent circuit. So here this is just a second. Okay, the equivalent circuit of this is RS. Okay, and we have a voltage source plus minus Vs, and as I said you that we will now get R1 and R2 in parallel. So R1, and we do have R2, R1, R2. Okay, and then we have a transistor, right? So transistor should be replaced with its H parameter equivalent circuit. At the input side, we have HIE and a voltage source, and the magnitude of voltage source, this is HIE, whereas this one is HFE into IEC, HRE into VC, sorry. This is HRE into VC. We need to remember this one. So HRE into VC, and here the current flowing is, this is base terminal, right? So here this is base, so IB current is flowing, and this is the emitter terminal, and the voltage across this one is VB. Okay, and now coming to the output side, we have a current source whose magnitude is given by HFE into IB, and we do have a resistance in parallel, that is HO, and we do have a resistance RL, which is now connected to the ground, across which we are going to measure V0, which is also equals to VC, and the current flowing through this one is IL, and the current flowing through the collector terminal is IC. This is emitter terminal, so it is grounded, right? So this is the equivalent circuit of the common emitter configuration. So here one more thing, as we are grounding the emitter bypass capacitor also. So if I short circuit this one, the voltage drop across this one will be 0. So in parallel voltage is same. That means this RE will also be short circuited. So that is why we will not get RE here, because we are short circuiting the emitter bypass capacitor. So the emitter resistor will also be short circuited. So that means there is nothing connected to the emitter resistor as we are doing the AC analysis. So emitter is directly connected to the ground, right? So this is the common emitter amplifier, right? So now first of all, the impedance that we can see from the input port is called as Ri, whereas this one is Ra dash. So what is Ra dash? Ra dash is equals to Ri in parallel with R1 in parallel with R2. First of all, let us find the parallel combination of R1 R2. So what is R1? R1 is 27K. So 27K into 27K divided by 27K plus 27K. So which is almost we'll get 13.5K. This is the value of R1 in parallel with R2. That we need to remember. Okay, now let us try to find out AI, current gain. What is the formula of current gain? Just now we have seen minus HFE divided by 1 plus HOE into RL, right? We don't have any collector resistance. RL is considered to be load resistance across which we are taking the output. So that is why RL. So minus HFE. What is the value of HFE here in the problem given? It is 85 minus 85 divided by 1 plus HOE. What is the value of HOE? That is 25 into 10 to the power of minus 6 into RL. What is the value of RL? RL value is 4.7 kilo. That is 4.7 into 10 to the power of 3. Okay. So here this is the value of this is the value of that current gain. So we will be getting it as negative. Just calculate this value and find it out here. So you can just find out the value of this, evaluate this value and substitute here. Okay. So next, this is AI. So AI value, I hope you can calculate it using the calculator. So this is the current gain. Next thing is input impedance. Input impedance. How to calculate the input impedance? I'll just give you the procedure. You just calculate the numericals and you can find out the value here. So the formula of input impedance is Ri is equals to HIE plus HRE into AI into RL. AI into RL. Just now we have seen the formulas. That is HIE plus HRE into AI into RL. So we all know the values of this one. So what is HIE? HIE value is given, that is 1 into 10 to the power of 3 plus HRE value. What is the value of HRE? HRE value is 2.5 into 10 to the power of minus 4 into AI value. From this we are going to calculate this one and just put it here. And RL value is 4.7 into 10 to the power of 3. So if you evaluate this value, you can have some value, and that is input impedance. So this is the value. This is the way of finding out the input impedance. Now coming to the next parameter, that is, so as I told you that Ri dash can be calculated as Ri in parallel with R1 in parallel with R2. So as we did not get the value of Ri, so just use the value. So use a formula and calculate it. And already we have calculated the value of this R1 in parallel with R2. That is 13.5K. So just substitute and find out the value of Ri dash. And now we are going to calculate the voltage gain. So the next one is voltage gain. Voltage gain, so which is represented with AV without taking the voltage source into consideration. So the formula for AV is AI into RL divided by RI. AI into RL divided by RN. So this is the voltage gain of transistor. So that is why we need to consider only RA. So that is AI value we don't know. RL value is 20 up to 4.7 kilo ohms. Substitute, and RA value we also don't know. Just calculate it and substitute it. Using this formula, we can calculate the value of AV. And now next thing is output. Next thing is output admittance. Okay, so that is output admittance, that is represented with Y0. Okay, so here what is the formula for Y0? So we already know that the formula for Y0 is given by HOE minus HFE into HRE divided by HIE plus HIE plus RS dash. Okay, HIE plus RS dash. What is RS dash? RS dash is nothing but we are taking the voltage source also into consideration. If you take voltage source also into consideration, then RS dash can be given by RS in parallel with RA dash. Okay, where RA dash is nothing but RA in parallel with R1 in parallel with R2. You just substitute this value in this one so that you will be getting Y0. So that is after getting Y0, the output admittance R0 can be obtained by taking the inverse of Y0. So this is output admittance formula. So here from the output admittance we have calculated this. So here if you see this equivalent circuit, the output impedance or else output resistance is a resistance that we can calculate from the output port that we can see when we are looking into the output terminal. So here now this one is nothing but R0 dash. What is R0 dash? If I replace this one entire thing with R0, this R0 will be in parallel with RL. So and hence the overall output impedance, that is R0 dash, can be calculated as R0 in parallel with RL. So from this you are going to calculate R0 and just take the parallel combination of R0 and RL dash, R0 and RL, then you can calculate this one. So here he didn't ask AVS and AIS, but here we can also find AVS and AIS. What is AVS? AVS is nothing but the overall voltage gain. Overall voltage gain. Okay, so when you take the overall voltage gain, so we have to replace the entire thing with the equivalent circuit. So here this one is RA dash. So what is this one? This one is nothing but this is the voltage, that is VB, whereas this is the input voltage source and this is RS, and the current flowing is IB, right? So here AVS can be calculated as V0 by Vs. So we are multiplying and dividing this one by Vb. So here V0 by Vb into Vb by Vs. To calculate Vb by Vs, so I am taking Vb, that is voltage divider principle, Vs into that resistance Ra dash divided by Rs plus Ra dash. So from this you can calculate Vb divided by Vs as Ra dash divided by Rs plus Ri dash, right? So now AVS can be written as AV. This is nothing but voltage gain of the transistor, that is V0 by Vb into Ra dash divided by Rs plus Ra dash. So by using this formula, we can calculate the overall voltage gain. And similarly, we can calculate the overall current gain. Overall current gain, that it is represented as AIS. So AIS can be calculated as here AI into IS by IB. So where IS by IB, so I can write this one as, this is the current source and this is in parallel with RS, and this one is we do have R1 in parallel with R2, and we do have this RA. So the current flowing is IB here. So IS by IB can be written as according to the current divider principle, IS by IB can be written as opposite resistance RS divided by RS plus RI dash. So this is the equation. This is the equation of current flow. This is the equation for finding IS by IB. So now after doing this, IB by IS. IB by IS, this is IB by IS. So just substitute these values, then you can calculate the overall current gain. And now let us see the second problem. The common emitter circuit has the following components. RL is equals to 47K, 600 ohms and RS is 600 ohms. The transistor parameters are given here. So here also we need to consider HRE as 2.5 into 10 to the power of minus 4. Determine AI, AV, RI, R0 and AVS, AIS. So here, what is the difference between the previous problem and this one? In that problem, we have R1 and R2 also. But here we don't have R1 and R2. So directly using the formulas, we can calculate AI. So first of all, what is AI? Minus HFE divided by 1 plus HOE into RL. So what is minus HFE? Minus 85 divided by 1 plus HOE value is 25 into 10 to the power of minus 6 into RL value. RL value is also 47 into 10 to the power of 3. If you calculate this value, this value, you will be getting the current gain as minus 39.08. Minus 39.08. Now calculate RI. So what is RI? HIE plus HRE into AI into RL. So HIE is what? 1 kilo ohm. That is 1 into 10 to the power of 3 plus HRE. What is the value of HRE? 2.5 into 10 to the power of minus 4 into AI. AI value is minus 39.08 into RL. RL value is 47 into 10 to the power of 3. So if we calculate this RI, the value of RI will be 540.08 ohms. This is the input impedance. This is the input impedance of the common emitter amplifier. Once it is done, now let us calculate AV, and the formula for AV is AI into RL by RI. So here AI into RL, AI value is minus 39.08 into RL value is 47 into 10 to the power of 3 divided by RI, that is 540.08. So now if you calculate this AV value, you will get it as minus 3.39 into 10 to the power of 3. This is the value of AV. So after calculating this AI, AV, then we are going to calculate first of all, as we have calculated RI, so we don't have any other resistances. So RI is simply we have because we don't have any other extra resistances R1 and R2. If we have, then we need to calculate RI dash also. Okay. Then Y0. So Y0 is given by HOE minus HFE into HRE divided by HIE plus RS dash. What is RS dash here? So RS dash is nothing but RS in parallel with RI. Okay, no need to consider this. So because we don't have any other resistances, simply we need to calculate RS here. So that is HIE into RS. So HOE value is 25 into 10 to the power of minus 6 minus HFE value is 85 into HRE value is 2.5 into 10 to the power of minus 4 divided by HIE is 1000. 1K means 1000 plus RS value is what? That is 600. So if you calculate this Y0, the Y0 value will become 11.72 into 10 to the power of minus 6. And if you want to calculate the output impedance, 1 divided by Y0, that is 1 divided by 11.72 into 10 to the power of minus 6. So if you calculate R0, the value of this one is 85.32 mega ohms. 85.32 mega oh sorry, not mega ohms, it is kilo ohms. The value of R naught is 85.32 kilo ohms. So this is the value of R naught. So similarly, we can also calculate R naught dash, which is equals to R naught in parallel with RL. So what is R naught? 85.32 into 10 to the power of 3 in parallel with RL. What is the value of RL? That is 47 into 10 to the power of 3. If you calculate the parallel combination of this one, then I'll get R naught dash value as 28.36 kilo ohms. This is the value of R naught dash. Okay, so once it is done, then we need to calculate AVS. So how to calculate this AVS? So AVS can be calculated as, so we have RS and we have RA in RA here, and the voltage drop across this one is VB and this one is RS, and we do have a voltage source, that is plus minus Vs. So here the current flowing is IB. So AVS can be written as V naught output voltage to the input voltage Vs. So I'm multiplying and dividing this one by this one. So V naught by VB into VB by Vs. Right? So V naught by VB can be written as AV into VB by Vs. So from this circuit, I can calculate VB as Vs input voltage into that resistance by total resistance, Rs plus Ra. So I can calculate this one as Ri divided by Rs plus Ri. So what is the value of AV we have got? That is minus 3.39 into 10 to the power of 3, 39 into 10 to the power of 3 into Ra value. What is the Ra value we have got? Ra value we have obtained as 540.08. 540.08 divided by, this is 600, Rs value is 600 plus 540.08. If I calculate this one, I'll get AVS value as, that is the overall voltage gain value, will be minus 1.60 into 10 to the power of 3. So this is the value of overall voltage gain. Now similarly, we can also calculate overall current gain, that is AIS. How to calculate this AIS? So AIS is equals to, so we can calculate it as I naught or else IL divided by IS. Okay, so here I am multiplying and dividing this one by IB here. So now I can write this one as I naught divided by IB into IB divided by IS. So this one I can write it as AI into IB divided by IS. So now what I am doing, I am just converting this equivalent circuit into Norton's equivalent circuit. So this is the Norton's equivalent circuit. Ri, this is, and this one is 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 flowing here, and across this the current flowing is IB. So now I want to calculate IB. So IB is equals to input current into opposite resistance, that is Rs divided by Rs plus Ri. So here that means IB by Is is equals to Rs divided by Rs plus Ri. So that is AI into Rs divided by Rs plus Ri. So just substitute all these values here, and what is the value of current gain we have got? That is current gain we have obtained it as minus 39.08 into Rs is 600 divided by 600 plus 540.08. If I calculate this one, I'll get the overall current gain as minus 20.55. This is the overall current gain. So this is how we can solve this problem. Okay, now the next thing is, so that is the another case where we don't have any other resistors and all. So now this is one more kind of problem we have here. So that is Rs is equals to 1 kilo ohms, and R1 is 110 and R2 is 12 kilo ohms. RC is 6 kilo ohms. H parameters are given here, and draw the hybrid equivalent circuit, equivalent hybrid model, and calculate this one. So first of all, I'm drawing the equivalent circuit. So that is, so we have R1 and R2, right? And we don't have RE here. and we have RC, whereas we are taking the output across this one. This is V0, this is RC, R1, R2, we do have RS, okay, and we have a voltage source, that is VS, this is RS, right? So now this is grounded. So this is the equivalent circuit. This is V0 we are taking. So this is the transistor circuit for the given specifications. Now draw the equivalent circuit here. So if we draw the equivalent circuit, so what happens? We have a source resistance in series with a voltage source, and we do have R1, R2, because we are grounding the, we are short circuiting the DC source, so that R1 and R2 will now be connected between base and emitter. And this is the equivalent circuit hybrid parameter model of the transistor, that is HRE into VC, and this is HIE, and the current flowing is IB, and the voltage drop across this one is VB. And now coming to the output side, we do have HFE into IB, and we have HOE, and we have RC now, across which we are going to take the output. Across which we are going to take the output here. This is RC. And here the current flowing is IC, and this one is IL, let us consider. So this is the equivalent circuit of the transistor. This is emitter, base, collector. This is VS, RS. This is the equivalent circuit. And we already know the formulas. What are that? AI is equals to minus HFE by 1 plus HOE into RL. In place of RL, we have to use RC, because we don't have RL given, right? So RL is equals to RC we have to take. So RC. So just substitute all the values and find out this one. And similarly, RA is equals to HIE plus HRE into AI into RL. So AI you are going to calculate from this, substitute and find out RA. Once it is done, then RA dash. So this is what? RI, and this is RI dash. This is RI dash. So RI dash can be calculated as RI in parallel with R1 in parallel with R2. So RI you are going to calculate from this. Just substitute this in this equation so that we can calculate RI dash. Now similarly AV. What is AV? That is AI into RL divided by RI. Just substitute all these values so that we can calculate AV. And now R0. So for that, first we need to calculate Y0. So HOE minus HFE into HRE divided by HIE plus RS dash. What is RS dash here? RS dash will be RS in parallel with R1 in parallel with R2. Okay, or else we can also consider R1 in parallel with R2 as RB. R1 in parallel with R2 as RB. So here in this case, this is the thing. So if you substitute this, then you can calculate Y0, and from Y0 you can calculate, you can calculate output impedance by taking simply the reciprocal of that. And now, the next case is we are going to calculate the overall voltage gain. For that, we have to consider the voltage source, that is RS, and we have RA dash here, and this is VS plus minus VS, and the voltage drop across this in parallel voltage is same, so that is why VB we are considering. So AVS is equals to AV into, similar to the previous problem, AV into RS divided, RI dash divided by RS plus RA dash. So just substitute all the values, calculate. And then AIS. So AIS, so what we need to do? So AIS is equals to IL by IS. So we can also write this one, we can also multiply and divide this one by IB. So IL by IB into IB by IS. So where I can write this IL by IB as AI into IB by IS. So here now what happens if I am converting the voltage source into current source? That means if I am replacing the input circuit with a Norton's equivalent circuit, So this one is nothing but Rs dash, and here this one is nothing but Ri. So what is the current flowing? This one, this is Rs, Is, and here in this one the current flowing is Ib. So now I can calculate Ib as the input current Is into opposite resistance, that is Rs dash divided by Rs dash plus Ra. What is Rs dash here? Rs dash is nothing but Rs in parallel with R1 in parallel with R2, that is Rs in parallel with Rb. So this is Rs dash. Okay, this is the total resistance. So that is how, that is AIS can be written as AI into, that is IS by IB by IS can be written as Rs dash divided by Rs dash plus Ri. So this is how we can calculate all the parameters. So if in any problems, if he asked us to find the power gain, simply we can calculate it as a multiplication or else product of voltage gain and current gain. So this is the solution of all the problems on common emitter configuration. I hope you all are clear with this concept. So I hope you can solve any of the problems on common emitter configuration. So the thing is, you need to remember the H parameter values and the basic formula of transistor circuit so that you can solve any kind of problems. That's all for this lecture. Thank you. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.